Standards for experimental words. Experimental words is one of the approach that the researcher use in their investigation program in order to find answers for their research questions. It is normally conducted as a simulations to the actual situations, which are too complex in the reality, where the governing factors that influence the response of a subject that intend to study are beyond control of the researcher. With that, the researcher will analyze the actual situations, identify the governing factors, or hypothesize the governing factors, trying to replicate the situations as a simulations in a manageable size to the lab scale under controlled situations where they can manipulate the factors that can govern the response of the subject to be studied. From the experimental tests, through relative comparisons of different specimens, and by manipulating certain variables, the researcher observed the influence of those variables to the behavior of the specimens. From there, the researchers are able to explain the actual situations, provided that it is properly simulated. All these need to build on the basis that the experimental tests can strongly resemble the actual situations, or else it will be meaningless. Therefore, the experimental works should be rigorously conducted in order to acquire the reliable results. And normally when we talk about the experimental works, our first option is to search for the relevant standards for the procedures, specifications, analysis of the tests, as well as for the test results. As most of the common testing will have the procedures well established to ensure the consistency in terms of the testing, as well as the reliability of the test results. There are many standards in the market, for example, British Standard, STM, and etc. The typical content within the standards include the scope, definitions, apparatus, sample specifications and preparations, procedures, test setup, as well as the analysis. When a testing word is established within the standard, the researcher throughout the world who comply with the standards will have a similar set of testing procedures, using similar set of apparatus, adopting the similar process of preparations of the specimens, conducting similar tests, and then using the similar procedures to analysis. This allows comparison in terms of the results as acquired by different researchers in case that cross-referencing is required. The standard provides a guide to the researcher in terms of the proper procedures that minimize the possibility of errors and mistakes, so that the testing yields a good result for analysis. However, due to a variety of topics to be studied within the research community, different kind of cases that can be studied, simulating different scenarios in the actual situations, sometimes the researcher may find that their experimental work may not have any standards to cover, which is yet to be established, or the researcher may not aware the presence of the respective standards. The standards of similar experiment may be referred. You may adopt the working principles for the relevant standards, where some modifications may be imposed. Of course, this has to be done carefully as necessary to suit the conditions of their investigations. The standard will serve as a guide, especially for those popular testing, As for those which are rather new, the researcher may develop their own testing program. These are some of the examples of the standards giving guides to conduct the experimental tests, such as lump test for the concrete, compressive strength of the concrete, tensile test of the steel, standard specifications for concrete facing brick, the floor test for the cement mortar, tensile test for mechanical splice, static load test for the wall frame structures, and etc. There are many more. If you're involved with the experimental work, you should try your best to search for the relevant standard. It will be safer for you in case that there are inquiries regarding the regularness of your experimental work by your supervisor or examiners. If you strongly abide to the recommendations and the guide given by the standards, at least we know that your results are more reliable as compared to those developed by yourself. In the case that you are developing your own testing program, the entire testing process needs to be clearly stated, and there should be discussions. How do you ensure the reliability of the results? Now let us look at an example of the testing program for lateral load test of wall panels. This is acquired from the standard listed here. You will need to read through the entire standard and evaluate it whether it is applicable for your case. Some may not be perfectly fit your conditions. Modifications may be made without compromising the principle behind those testing procedures. Let us have a quick look through the procedures and try to identify the principles and reason behind it. You know that this kind of testing, it is applying a horizontal force parallel to the base of the wall panels. And this horizontal force, it can be along the connections between the base and the wall, or it can be at certain height from the base of the wall panel. And this is meant for the static load. That means the loads will be applied there in the same positions throughout the testing. The load will increase stage by stage, which should be maintained for a while before the readings are taken. These are the list of the procedures as outlined by the standards. Apply load parallel to and at the top of the wall and in the center plane of the frame using a hydraulic jack. That means this gives you an idea where you should apply the load, and then maintain a constant displacement rate for continuous load to failure, or holding a static load in the case of incremental loading. This gives you two options of increasing the load. One is increasing in terms of the displacement rate. The load can be continuous and the displacement of the wall panel will be quantified, and to observe gradual increment in terms of the displacement of the wall until the failure of the wall. Or the second way it is conducted is holding the load as a static load when you need to increase it stage by stage. If you are conducting the testing by the constant displacement rate, you will need to make sure that it takes not less than 5 minutes to reach to the target limit, that is the limiting displacement at the ultimate load. That means this entire testing, if you use the constant displacement rate, must take longer than 5 minutes. It shouldn't be too fast, as this is going to influence the ultimate capacity due to the inability of the stress to be properly distributed within the structural element that can lead to premature failure of the specimen. Or if you use the static load incremental approach, you will need to maintain the durations of load applied to each increment at least 1 minute before the displacement readings are recorded. That means if you use the approach where you increase the load stage by stage, you will need to maintain the load for at least 1 minute to allow the stress to be properly distributed within the element before the displacement readings are recorded. For those who have experience with the experimental test, once you increase the load, you will see some fluctuations of the readings. You will have to wait until the readings more or less stable before you can record the reading. Otherwise, the readings that you have acquired may not be accurate. You need to apply preload for about 10% of the ultimate load. Hold for 5 minutes to seat all the connections. This is a precaution procedures to exercise the specimen, settle everything within the test setup so that whichever readings that acquired during the testing later will not be due to the settlements of some connection joints within the test setup. This can be eliminated. For this test to be conducted, you need to have certain ideas in terms of the ultimate load capacity, which is estimated. It doesn't have to be very accurate, as you may not know the actual capacity. At least you have an estimated figures. You need to hold the loadings for 5 minutes before you remove the load, and then wait for another 5 minutes and set all the gauges as the initial readings. That means you are about to officially start the testing. This process is quite important as a preparations for your testing. Now you're going to start your testing. Based on the estimated ultimate load, you're going to increase your load to about 1/3 and 2/3 of the ultimate load, which you estimated earlier, and then remove the load and record the recovery of the wall after 5 minutes. That means there are 2 cycles of load here. The first cycle, it will be from 0 to 1/3 of the estimated ultimate load, and then going back to 0. This leads to second cycle, which is from 0 to 2/3 of the estimated ultimate load, and then going back to 0 again. The entire response of the specimen shall be recorded and monitored throughout the testing. Next, you reload again to the next higher load level until the ultimate load is reached. This will be the third cycle where you're going to fail the specimen. This is a typical 3-cycle loops applied laterally to a wall panel in terms of the static load. It is not a dynamic load and it is not a cyclic load. Based on the testing procedure here, you will be able to acquire the stiffness of the wall panel as a resistance to the horizontal load during the first, second, and third cycle. The first cycle is to the 1/3 of its estimated capacity. The second cycle, it will be to the 2/3 of the estimated ultimate capacity. And the third cycle, it will be until to the failure of the specimen. You will be able to observe whether there are permanent deformations at the end of each cycle before the next cycle is triggered. You're going to see the ability of the wall panels to recover to its original positions, as well as you're going to observe the changes in terms of the stiffness as a reflections in terms of the implications of the damages occur during those cycles. And then you're going to acquire the ultimate capacity of the specimen. There are quite a number of informations that you can acquire from this testing. For more details, you may refer to the standards. The standards even give you some formulas to do the analysis as a guide to you. How do you analyze and interpret the response of the wall panels? Next, let us look at another example. This is given by the standard here. It is regarding the test procedures for the testing of the mechanical splice. The mechanical splice is a coupler which is used to connect two steel bars within it, preventing the steel bars to slip out of the coupler so that the stress can be effectively delivered from one steel bar to another steel bar. It is considered as a connections to the steel bars. These are the typical procedures as outlined by the standard. Place the specimen into the testing machine such that tensions or compression load can be applied axially without any eccentricity. That means this kind of testing can be used for testing the tensile strength of the mechanical splice, or it can be used to test the compressive strength, or it can be used to test both, which there will be tension and compressions oscillating throughout the experiment. The important thing here is you need to ensure the load is applied axially to the splice without any eccentricity. We do not want the eccentricity to affect the accuracy of the results. The end of the specimen should be held in the test machine such that tension loads and compression loads, or both, can be applied to the specimen without movement of the specimen within the grip of the test apparatus. That means you need the specimen to be properly gripped at the reinforcement bar here, such that the splice here is in the static conditions, and when the grip moves up or down in the process of generating the tension and compressive force, there won't be any external force acting onto the splice. Then you need to put more than 2 elongations measuring devices that continuously monitor the elongations equally spaced around the test specimen. That means there will be 2 elongations measuring device placed at the predefined locations, which is equally spaced from the end of the coupler. And this measuring device needs to be attached to the reinforcement bar next to the coupler, such that the resulting total gauge length equals to the length of the coupler, which is this length, plus 2 to 6 bar diameter. That means the summations of 2z here should be equals to 2 to 6 times the diameter of the bar being spliced. In fact, based on the diagram here, it gives you an idea that you are testing a coupler, which is this, being used to splice 2 bar, which is bar 1 and bar 2. And this 2 bar here is to be embedded inside the coupler. The standard recommends you to use 2 extensometer, which is used to measure the elongations happening at 2 points of the specimen, which is point 1 and point 2 here. These 2 measuring devices need to be placed at the opposite directions, and the result taken will be an average of the 2. And the distance between the 2 points here, it will be equals to the length of the coupler plus 2z here. The z here, as a summations of the 2z, should be about 2 to 6 times the bar diameter. That means for 1z here, it will be about 1 to 3 times the diameter of the bar it is being spliced. It is optional for you to install another extensometer to measure the extensions happening within the coupler. For more details, you may refer to the standards. This is just an example to you regarding the usage of the standards for the experimental works. Normally, they have the procedures to be properly outlined, and if possible, you have to comply to all the procedures as recommended by the standards.